The third rule we deal with non-right angle triangles is find the area of a triangle. So, like in the cosine rule, to find the area of a triangle, we need two sides and the included angle. So, we've got angle C and angle B, side C and side B, we need angle A. Or if we've got C and A, we need B, B and A, we need C. So, the rule for this one would be half AB sine C. So again, if you want the proof of that rule, find your textbook or have a look for the proof of the area of a triangle with the sine ratio on the net. But otherwise, quite happy just to apply the formula. But keep thinking in mind, what do I need? I need the two sides and the angle between them to work with that. So if we have a look here, we've pretty much laid out. We've only got the two sides and the angle between them, so there's not much to get around in this case. So we've got the half times the 6 times 7 times sine of 96 all into the calculator would give us 20.88. So there's our rule. Again, write down the application of the formula, then you're able to calculate it straight with the calculator there. The area of this triangle, we've got two sides, angle between them, so we apply our formula, write the values in, put it in the calculator, get 27.17. So it's just a case of rounding it correctly in that one. So again, what are these ones? We've got two sides and the angle, but one side's missing. We've got our area. So we're manipulating our formula this time. So 12.4 is a half times x times 5 times sine 50. So we calculate the half times the 5 times the sine 50 and get it in the calculator. We have x times the 1.195. Divide by the 12.4 by the 1.915 to get x by itself. We get x is equal to 6.47, which sounds reasonable. That's going to, if we throw it back in, that should give us a 12.4. Again, we're able to solve an equation. We can sub it back in to check if it works. So we've got the 4 and x, 12 millimeters. Again, applying our formula, calculating the half times 4 times sine 46 gives us the 1.4386 and keeps going. Divide 12 by that, and we get 8.34. And this time we've got 100 millimeters, 100 meters squared with x meters and 63 meters. So, and our angle of 34 degrees 14 minutes. So we put that into the calculator to get the x times 17.720. Divide 100 by the 17.720 and so on, and gets 5.64. So that's how we're able to manipulate our formula to solve a problem that's a little bit different. So here's one where written in words. You got three towns here connected by a series of straight roads, and we've got that from A to C is 19, and we get from A to B here, it would be 14. So when we set it all up, the angle formed by the Alstonville to the roads is 76 degrees. So we calculate the area between the roads joining the three towns. So we set it up our triangle with the three towns, and then get the angle sides, the angle between them. We're able to put in our values to get the area there. Try not to forget our units, kilometers squared, and that will help us identify that we're actually finding an area there. So there's our area formula and the process to it. Get your formula, find the data, apply the formula, calculate it, and that will give us our area.